So I have this bottle here, used to have some soap in it. It's empty right now. There's just maybe a little bit of water in it, but it's mostly air inside. And that air is less dense than water. If we look at this bucket, it's full of water, and there's some air on the top. The air is higher up because it is less dense. So the less dense, the higher it will be up on it. Now, if we look at this bucket here, I'm going to stick this bottle on top of the water. It's going to float. Now, why does it float? Because most of its contents are air. It's plastic and air, but the average of its density, so if you took the volume of this, which is 259 milliliters, and you took the mass of it and divided it, it would be less than 1. It'd be less than what this water is, which we learned in our last activity. But as this fills with water, so I'm letting it sit there, you're going to see it's filling with water. There's a certain point where it starts to sink. So it's sinking a little bit. The side that's filled with water has more mass, which means it's more dense. So it's going to slowly sink. Now I'm going to push down on this side, add some force so it fills up, and eventually, oh, it's still floating, but the side that has oxygen in it and nitrogen, different air gases, fills, and at a certain point, now it's sinking. Why? Because it's filled with water. So now the average density of this bottle has become greater than the water, so it has sunk all the way to the bottom. I'm not holding it down anymore. Okay. If it's upside down, the pressure keeps the water from getting into the bottle. The pressure, because it's a closed system, and we'll talk about that later in the year. So I'm not going to talk too much about that, but it'll cause this to float back up. It'll float back up. This just shows that something that has the same volume can have different densities just based on what's inside of it. The more mass that's inside of it, the higher the density. The lower the mass, the lower the density.